For the next video, I'm going to discuss to you all about the topics in Chapter 7 entitled IP Addressing. Addressing is a critical function of network layer protocols. Addressing enables data communication between hosts regardless of whether the hosts are on the same network or on different networks. Both Internet Protocol version 4 or the IPv4 and Internet Protocol version 6 or the IPv6 provide hierarchical addressing for packets that carry data. Designing, implementing, and managing an effective IP addressing plan ensures that the networks can operate efficiently and effectively. Binary is a numbering system that consists of the numbers 0 and 1 called bits. In contrast, the decimal numbering system consists of 10 digits consisting the numbers 0 to 9. Binary is important for us to understand because hosts, servers, and networks devices use binary addressing. Specifically, they use binary IPv4 addresses to identify each other. Now we're going to proceed the needed for IPv6. IPv6 is designed to be successor to IPv4. IPv6 has a larger 128-bit address space providing for 340 antecedent addresses. That is the number 340 followed by 36 zeros. However, IPv6 is more than just larger addresses. When the IETF began its development of a successor to IPv4, it used this opportunity to fix the limitations of IPv4 and include additional enhancements. One example is Internet Control Message Protocol version 6 or the Icmp v6, which includes address resolution and address auto-configuration not found in Icmp for IPv4 or the Icmp-v4. Icmp-v4 and Icmp-v6 will be discussed later. Need for IPv6. The depletion of IPv4 address space has been the motivating factor for moving to IPv6. As Africa, Asia, and other areas of the world become more connected to the internet, there are not enough IPv4 address to accommodate this growth. IPv4 has theoretical maximum of 4.3 billion addresses. Private addresses in combination with network address translation or the NAT have been instrumental in slowing the depletion of IPv4 address space. However, NAT breaks many applications and has limitations that severely impede peer-to-peer communications. The internet of today is significantly different than the internet of past decades. The internet of today is more than email, web pages, and file transfer between computers. The evolving internet is becoming an internet of things. No longer will the only device accessing the internet be computers, tablets, and smartphones. The sensor-equipped internet-ready devices for tomorrow will include everything from automobiles and biomedical devices to household appliances and natural ecosystems. IPv4 and IP version 6 coexistence. There is not a single date to move to IPv6. For the foreseeable future, both IPv4 and IPv6 will coexist. The transition is expected to take years. The IETF created various protocols and tools to help network administrators migrate their network to IPv6. The migration techniques can be divided into three categories. We have the dual stack, the tunneling, and the translation. First, the dual stack. It allows IPv4 and the IPv6 to coexist on the same network segment. Dual stack devices run both IP version 4 and IP version 6 protocol stacks simultaneously. The next one is the tunneling. It is a method of transporting an IPv6 packet over an IPv4 network. The IPv6 packet is encapsulated inside an IPv4 packet similar to other types of data. Then the last one is translation. It is a network address translation 64 or the NAT64 allows IP version 6 enabled devices to communicate with IP version 6 enabled devices using a translation technique similar to NAT for IP version 4. An IP version 6 packet is translated to an IP version 4 packet and vice versa. Note that tunneling and translation are only used where needed. The goal should be native IP version 6 communications from source to destination. The Icmp version 4 and the Icmp version 6. Although IP is only a best effort protocol, the TCP or the IP suite does provide for message to be sent in the event of certain errors. These messages are sent using the services of Icmp. The purpose of this message is to provide feedback about issues related to the processing of IP packets under certain conditions, not to make IP reliable. Icmp is available for both IP version 4 and IP version 6. Icmp version 4 is the messaging protocol for IPv4, and then the Icmp v6 provides these same services for IP version 6 but includes additional functionality. The types of Icmp messages and the reasons why they are sent are extensive. There are different Icmp messages in both Icmp version 4 and Icmp version 6. It includes the net unreachable, host unreachable, protocol unreachable, and port unreachable. We all know that IP addresses are hierarchical with network, subnetwork, and host portions. An IP address can represent a complete network, a specific host, or the broadcast address of the network. Understanding binary notation is important when determining if two hosts are in the same network. The bits within the network portion of the IP address must be identical for all devices that reside in the same network. The subnet mask or prefix is used to determine the network portion of an IP address. An IP address can be assigned either statistically or dynamically. DHCP enables the automatic assignment of addressing information such as IP address, subnet mask, default gateway, and other configuration information. The IP version 4 host can communicate one of different ways: the unicast, broadcast, and multicast. Also, blocks of address that are used in networks that require limited or no internet access are called the private addresses. The private IP version 4 address blocks are 10.0.0.0/8, then 172.1600 and so on. The depletion of IP version 4 address space is the motivating factor for moving to IP version 6. Each IP version 6 address has 128 bits versus the 32 bits in IPv4 address. IP version 6 does not use the dotted decimal subnet mask notation. The prefix length is used to indicate the network portion of an IPv6 address. Using the following format, the IPv6 address, then the prefix length. Now we're done in summarizing the Chapter 7.